Hi, my name is Nick Bridle, and I'm a computer science student here at Rice University. And I'm going to show you how to track your hands in 3D space using the Nintendo Wii controller known as the Wiimote. On the end of the Wiimote, there's an infrared camera that can pick up to 4 infrared points at once in space. And basically, using these gloves, very nice shade of green, that we've made, on the fingertips there are infrared LEDs, and actually they're pointing in 2 different directions. And basically, the theory is that if you have 2 Wiimotes on camera tripods facing inwards towards each other, you're actually able to calculate where points are in 3D space. So this is our physical setup. It's inspired by John and Lee's Wiimote finger tracking project, but instead of 1 Wiimote, we actually have 2 Wiimotes. Like I said, over here we have the Wiimote mounted on a camera tripod. We actually have 2 of them. And basically they're pointed inwards in order to give the concept of depth perception. So to use the system, the user will stand approximately halfway between and about 6 feet from the Wiimotes. And wearing the glove, they can actually hold it out, and both Wiimotes should be able to see the infrared LEDs on the end of the fingers. I developed a sample application to show what the geometry of the problem looks like. As you can see on the screen, as I move my hand up and down and left and right and forward and backwards, the cubes respond to where my finger is moving. And as you take a closer look, you can see there are actually 2 cubes. There's an orange one and a blue one. The orange one is the image of the point in the left Wiimote, and the blue is the image of the point in the right Wiimote. And as you can see, as I move left and right, and up and down, and forward and backwards, the cubes are following what I'm doing based on where the Wiimotes are picking up my finger. And I actually need both points to be able to calculate where my hand is in 3D space. Now I want to explain a little bit about how we calibrate our system. To do this, we use the calibration cube, which is a physical cube with infrared LEDs on each of the corners. The purpose of this is to show the Wiimotes and to indicate the general area in which we can track 3D points and perform hand gestures. So to calibrate the system, the user would step over here and hold it up in front of the Wiimotes. And as you can see on the screen, we have a number of points showing up. These are basically all the corners of the cube. We actually are aiming for 6 points at a time, because we're doing the front plane of the cube first, 2 infrared LEDs on each corner, for a total of 6 points. Once that's captured, we flip to the back plane, and now we show the back plane, in which we're also aiming to get 6 points. Now that we've calibrated, we're actually able to track my pointer finger in 3D space. You can see the red cube now is indicating where the 2 Wiimotes are calculating my hand is. You can take a closer look at the screen to see what's going on. The wireframe cube is actually the outline of where we calibrated that the unit cube is with our calibration cube. And the red cube, like I said before, is actually following my finger wherever it goes. I can do this arbitrarily fast, and do very fast movements, or very slow movements. I'll sort of move it up, down, left, right, and now forward and backwards. It's a little bit hard to see in this 3D view, but actually you can tell that the cube's moving away from the camera and into the camera. Now I want to explain a little bit about how we calculate points in 3D space. During calibration, we save the 3 points for the front plane and for the back plane. And basically once we've done this, each Wiimote knows where the 2 planes of the cube are located. Then for each Wiimote, we calculate the viewing ray from the Wiimote to my finger through the front and back walls of the cube. We have both of these rays for each of the Wiimotes, and then we can actually calculate the intersection point of these 2 viewing rays, and that point is actually where my finger is. Now sometimes these rays don't actually intersect. In fact, generally that's not the case. So what we can do is calculate the shortest line between the 2, and the midpoint of that line is actually where my finger is. With this 3D tracking, we can also recognize hand gestures. The way we're going to do this, I have 2 gloves here. Each of them have infrared LEDs on the fingers. And my primary hand, my right hand, I'm going to be actually tracing out the gestures, whereas the left hand is what I call my mode hand. Whereas if I show one finger to the computer, it says that I'm starting a gesture, and when I pull the finger away, it says that I've completed that gesture. So let's actually perform some 3D gestures. So actually take a closer look at the screen. Down here on the left, it actually says what gesture has been performed. It says too few points if it actually hasn't collected enough data. What I'm going to do is actually start to perform some gestures. So we draw a square, and it actually reads, the square has been performed. Also, we can do other shapes, such as the star. Additionally, we can do things like chevron down, and for sort of a 3D gesture we can recognize, we can move our hand in this fashion and recognize a 3D spiral. Here's a little bit how we actually recognize the gestures. What we're doing is, built into the operating system, specifically I'm using Windows 7, but into a lot of operating systems they actually have 2D gesture recognizers built in. I'm using a tablet PC, and I'm actually using the stuff for handwriting recognition as well as shape recognition that comes standard with the tablet PC SDK. So basically, once we have the data in the 3D space, we can project it to a 2D plane, and once we've done that, apply those recognizers, and we are actually able to recognize 2D shapes. If we want to do a 3D shape, like that 3D spiral I showed you at the end, basically what we do is take the points, project them to two planes, I have it on the front plane and the top plane, and apply a recognizer to both. And basically what the gesture looks like in two planes is actually going to correspond to a 3D gesture. In the case of the spiral, it would be a circle in the front plane and a zigzag on the top. And if we recognize both gestures at once, we've actually recognized a 3D gesture. I developed this input system as part of our Comp 410 senior design project here at Rice, and I hope you've learned a little bit about how to track points in 3D space using the Nintendo Wiimote.